Third time's a charm, right? You don't know it. This is the third time. Okay. So today, for the sixth time, we're going to talk about infinite limits. So what that means is that limits will either be going to infinity, so the x values will approach infinity, or the limits could equal infinity themselves, positive or negative. Okay, evaluating each limit. There are a few options that you can use when you are evaluating these with infinities. My option, my choice, would be to think about what infinity, or what it is if I actually substitute in, wow, come on, you can draw an infinity. I used to do circles next to each other because I couldn't actually draw the sideways infinity. So that works too. Okay, so if I put in that 1 over infinity, or the negative infinity for my x spot, which I will never actually show on any work because that is an indeterminate form, but 1 over infinity, so 1 over a very, 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 very large number might as well be 0. The other way to think about this is if I actually think about the graph of 1 over x, this is kind of a rough sketch, very ugly, super bad. As I go out to the left forever, my y values are tending towards 0. As I go to the right forever of 1 over x, or if I think about 1 over infinity, that is also going to 0. 1 over x squared, I believe that we talked about this in the first lesson, but 1 over x squared as I approach 0, so think about I am approaching 1 over, really doesn't matter whether it's positive or negative, 1/10. And the reason I say it doesn't matter is because I'm going to square that value. So it will always come out positive no matter what. So say I approach with 1/10, positive or negative, and then squared. I approach positive or negative 1 over 100th squared. Right? This number in the denominator is becoming smaller and smaller. So if I have 1 over 100, that's really equal to 100. If I have 1 over, yikes, 1 over 10000, this is really, what is that, 10,000? Right, so the numbers are becoming bigger and bigger and bigger as I am approaching 0 from either side. So what that is telling me is that this is going to infinity. And again, graphically, we looked at this the first day. As I approach 0 from both sides, my y values are going to infinity. Okay, next one. The limit as x approaches infinity of 5 plus 1 over x. I do want to remind you, I'm not ever going to write this, but this property is still in play for limits. So this is kind of how I think of it in my head, but I don't actually do it. But the limit as x approaches infinity for 5, just remember that 5 is just a straight line, so it doesn't matter what x value I approach from. That is always just going to be 5. So 5 plus, I know this other one was 0. 5 plus 0 is 5. Again, you will never see me write any of that work. You will just see me write 5. Okay, with this one, I like these to think about the horizontal asymptote. That is my preference. So in Algebra 2 and in pre-cal, remember that was just where it's like, is it bottom heavy, are they equal, or is it top heavy, so on and so forth. This one I would consider bottom heavy because I have an x squared in the denominator, where I have only an x to the first in the numerator. We will see one in a minute that they are equal to each other. But if I think about this in terms of infinities, that was a good infinity. If I have 3 times infinity plus 7, this plus 7 isn't really going to do anything. Infinity squared minus 2 really isn't going to do anything. So now if I simplify my infinities, infinity divided by an infinity is just 1 over infinity. So this is going to act like 3 over infinity, which we already explored. That 3 over a very large number, or any number over a very large number, such as infinity, right, can be 300,000, whatever it wants to be. As long as it is over infinity and it's just a number, then it's always going to tend towards 0 because infinity is insanely large. I can't even fathom it. It's so big! Okay. Negative 1 over x minus 1 squared as I'm approaching 1 from the left side. So the numbers that I am thinking of is I could plug in 0.9, 0.99, 0.999, so on and so forth. So all that means to me, is this difference is getting very, very, very small. So I'm going to be dividing by a very, very small number that is then squared. So it would be a very, very small positive number. So since it's going to be a very, very small positive number that I'm dividing by, let's say I think about it as negative 1 over 1 million. Very, very, very small, right? That really just means that this is going to tend towards negative infinity, because I would have to multiply by the reciprocal to get that up to my numerator. So it would be a very, 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 very large number divided by 1. All right, moving on. As I approach negative 4 from the left, if I put it in there, again, direct substitution is always my first go-to. I can put in negative 4 to the x squared, and that is just 16. If I put in negative 4 down here, though, I'm dividing by 0. So let's think about, I'm approaching from the left. Have a good night, Lucas. So I put in negative 4.1. Poor kid had to listen to me making these notes. Man, miserable life. If I put that in, my difference is going to be a negative small number. Right, and it's just going to keep getting smaller as I keep adding more zeros in front of that number, since I'm getting closer and closer to negative 4 from the left. So that means I'm dividing by a very small negative number. So overall, this part should be going to a very large positive number, or a very large negative number. Right, kind of the same idea as this one here. So since that is really 16 minus infinity, that 16 does almost nothing. So this might as well just be negative infinity. All right, moving on. My horizontal asymptote here, if you remember from pre-cal, algebra 2, the highest exponent is t to the 4th. So I really only care about the coefficients there. So this is going to tend towards 2/3. And that would be it. That's all the work I'm going to write. If you want to think about this in terms of infinity, and please remember, I talk intentionally fast to save you time if you are trying to just review, because you guys can slow me down. You can make me talk this fast. Or you can make me talk this fast. Whatever you want to do. Whatever makes you happy. I can't imagine what that sounded like in double speed. Okay, so the -1 and the -9 really aren't going to change my infinities. Even the 6 times infinity and the 5 times infinity are not going to do that much, because it is infinity to the 4th. That is so big. So infinity to the 4th divided by infinity to the 4th will divide and make 1. So that's how I'm also coming up with it will tend towards 2/3 as it goes. All right. Last thing, finding any vertical asymptote. So just remember, there's a few restrictions on functions, like I can't divide by 0. So here, x squared equals 0 is where I would have vertical asymptotes. All right, so x squared cannot equal 0. So I have vertical asymptotes at x equals 0. Those are not possible. Bad. Don't do it. Another restriction could come with natural logs. We'll get there in just a second. But like on part B here, right, I can't divide by 0. So this x squared plus 9 cannot be equal to 0. So just be careful. All right, some people tell me it's plus or minus 3, but if I try to solve this, when I take the square root, that's going to give me imaginary numbers. And congratulations, you've made it to calculus. We are no longer going to deal with imaginary numbers in this course, even though we did in pre-cal and algebra 2. Why do we do it then? Well, it'll be used otherwise in math. So you do need to know it, but just not for calculus AB or BC. Congratulations. With natural log, I cannot take the log of a negative number or anything less than that, or 0. So really, truly, my vertical asymptotes are going to happen if x squared minus 4 equals 0. If I solve that, that would give me to believe that there are 2 asymptotes at plus or minus 2. And this graph, if you take a look, see in your calculator, will look something-ish like that. Yay. Okay, last one. If I see a quadratic, then factor it. T plus 3 over, let's see, t plus 9 minus 6. Right, so I have 2 vertical asymptotes at -9 and positive 6. If, big if this were like plus 9 up top or something like that, then I would be able to divide those out. This would simplify to 1 over t minus 6. The rest of my function pieces would act like this function 1 over t minus 6, and I would only have one vertical asymptote at t equals 6. Okay, that's all I really got for you guys today. It was short and sweet. Please let me know what questions I can answer for you, and we will see you